Three, two, one. Okay, guys, this is the last section we will cover before your next exam. Just to revisit, over the course of the weeks that I've been gone, you guys talked about atomic structure, how atoms are, rather, what atoms are made up of, and then we went into depth a little bit on the periodic table. And this section we're going to cover water in solutions. So we're going to talk about the importance of water and what benefit it has to us as organisms, as well as the chemistry portion. So what it helps do within the human body, kind of at the cellular level. Within this section, we are going to do a couple different things. Of course, it wouldn't be a true lesson from Mrs. Sand if we didn't have some review in terms of worksheets, some illustrations, and then you guys do have a mini project with this. It is mini, okay? It's not one of those mini projects that end up taking us 10 days. And then we kind of wrap up this section with a Quizlet review. I know that's everybody's most favorite thing to do, especially when it comes to the gravity game. So as we go throughout, again, I cannot encourage you guys enough to make sure you guys include any information that I might talk about or any information that you feel you're not really sure of, and then when I come back next week, hopefully we can revisit and get everything clarified before the exam. I really don't have any additions on these guided notes, so just whatever you guys see on the screen, and a few things that I do add in when I'm talking is what you want to make sure you get down in the notes. Again, any questions, make sure you guys email me, and I'll try to get back to you guys as soon as possible. If not, just wait until next week when I get back. Alright, so to get started, okay, your lesson objectives. First, you guys will be able to analyze the properties of water. So like I stated, we're going to talk about the importance of water in terms for us. And then we're going to talk about the effectiveness water has when it comes to dissolving different substances, and identify and differentiate between acids and bases. So what type of ions are being produced in order to be classified as either an acid or a base. Your key terms for this section, we don't have very many at all, but we have cohesion, adhesion, solution, acid, and base. You guys will be responsible for knowing each of these. There are a few other terms throughout this section, so make sure you guys get those down and are aware of them. And we'll revisit those, we'll visit those as we get to those slides. Alright, so first and foremost, we're going to talk about why water is a major component of cells. You guys may have seen this first number or first percentage elsewhere because we say that 70% of the earth is made up of water. So with that being said, 70% of our body is made up of water. So if you guys have heard that 70% of the earth is made up of water, hopefully it's a little easier to remember this. 2/3 of the molecules within the human body are made up of water molecules. So this isn't just saying that just water is within your body and that's it. Rather, you're going to find water within the tissues, the muscles, the cells. Just about everything within the human body has water within it, just that varying amounts. So what is the importance of water? Well, for us as human beings and organisms, it does three different things. So first of all, provides a medium for chemical reactions to take place. So medium is just kind of a substance for chemical reactions to take place. Kind of helps keep that process going, as well as gives it an environment that is suitable for those reactions to take place. Also helps move nutrients and substances in and out of the cells. So when our cells say, hey, look, we need more nutrients, that water is going to provide that movement, as well as take away the toxic toxins when we're not feeling well. And then, of course, last but not least, hydration. Cannot stress enough, I know you guys have heard it before, but just the importance of being hydrated and just the benefits it provides for us. Okay, so make sure you guys are aware of these three different processes or things that water does provide for us. And if you guys are wondering, pregnancy brain does not go away after you have a baby, as you guys may have already been able to tell. Luckily, Dad has Miss Riley right now, and it looks like she's a little bit calmer. But water stores heat efficiently. So another benefit to water is its ability to retain heat. Okay, so when we think about all the molecules out there, water is probably our best in terms of storing heat. Okay, so water heats more slowly and is able to stay warm for a lot longer. So although we might think that, hey, it's taking forever for this water to heat up, well, in terms it is, just because it does heat more slowly, and although we think our hot coffees or hot teas get colder sooner, it's actually staying warmer for a little longer than many other substances. We release heat through evaporation. Of course, we do by sweating. And water helps maintain that stable internal environment, which remember is the term homeostasis. So again, guys, we're seeing stuff we learned way back when, here and now. So make sure you guys are not forgetting what we've already gone over this semester. Okay. Another benefit to water is its polarity. So water has that ability to bond to itself and other substances. So if you guys recall those 3 different types of bonds we talked about, your covalent, your ionic, your hydrogen bonds, it allows for cohesion to take place. So we're going to talk about 2 different terms here. Cohesion is the attraction between substances of the same kind. So this is when we see the drops. Little droplets on top of leaves or grass after it's rained or after they've been sprayed with water. If you guys look down here in the right hand corner, that's what I'm talking about. So your drops and thin films are then formed. This is all because of cohesion. Think about co-captains on a sports team. They're both working towards the same goal rather than, one working against the other, which is going to describe the next term. But cohesion, again, they're working together, so substances of the same kind are attracted to one another. Okay, again, this cohesion creates surface tension, and it helps prevent the water from stretching or breaking easily. One of the things we'll do when I get back, I would love to bring Riley to school with me, but one of the things we'll do is we'll look at the different substances in terms of how many drops we can get on top of the penny, and that will really help illustrate surface tension and cohesion. Adhesion, on the other hand, is the attraction between different substances, and adhesion and cohesion. So this is what I want you guys to add in here. Adhesion and cohesion powers a process known as capillary action. Okay, so again, make sure you guys add in where it says adhesion. Okay, where it says adhesion. Oh, my pen's not working. Alright. So where it says adhesion, make sure you guys add in cohesion here. Okay, adhesion and cohesion powers a process known as capillary action. This definition then is right below. Okay, so the definition to capillary action is this next bullet point. So whatever you guys got to do in order to make sure you guys have that on your notes is going to be super important. Okay, so water molecules move upward through a narrow tube. This attraction is stronger than the force of gravity acting upon it. So what's happening is cohesion and adhesion together are watering plants, and this is how they get that water needed in order for them to survive. One way to think of adhesion, think of anti. Okay, if I'm anti homework, I don't want homework, I want nothing to do with it, so therefore it's different from me loving homework and wanting to do it all the time. Okay, so again, make sure you guys know cohesion and adhesion, and make sure you guys are aware of capillary action and where this definition is. Okay, as I said, plants are watered this way, so between cohesion and adhesion, the molecules needed in order for survival takes place through capillary action. Okay, so this is just a diagram of how it's working. As it states, it's stronger than the force of gravity. Okay, so it's overcoming that force of gravity to where the plants are able to survive. And then eventually the water does leave through a plant organelle known as the stomata. So when it has enough water, then that excess water is going to leave through the stomata. Another benefit is water dissolves many substances. Okay, so what we're going to talk about here is a solution. I know you guys have heard that word before, solution and suspension. So your solution is defined as a mixture in which one or more substances are evenly distributed in another substance. So what I want you guys to think about is maybe Mio or any water additive you guys can put within your drinks. It's that even distribution. There's no particles left over. Let's say you guys use the Crystal Light packets. Sometimes you might have little chunks of it, I guess, left over. Whereas in your solution, it's going to be completely evenly distributed. So you're not going to have any particles floating within. It's going to be mixed evenly. So your solution is broken down into two different parts. Okay, so the first part is the solute. This is the substance that is being dissolved. Okay, whereas your solvent is the substance that is dissolving the solute. So example, a saltwater solution. Okay, your solute, what substance is being dissolved? It's the salt. Alright, whereas your solvent then is water. Okay, so make sure you guys are aware of these two terms, well really three terms, your solution, and that it's broken down into two parts. Okay, I know you guys have seen this word before. We talked about it in 2.1, and that's polarity. Recall polar molecules hold that bent shape. Okay, where your nonpolar molecules are going to be evenly distributed. Polarity is great in terms of dissolving substances. So how it works in terms of ionic compounds and polar molecules dissolve best in water. And we know water is a polar molecule because of its shape and the fact that your hydrogen molecules are more attracted to the oxygen molecule, which remember is stronger because it's more negative. Okay, so when ionic compounds dissolve water, polar molecules surround the ionic molecules and they have opposite charges. Those opposite charges attract and then dissolve effectively. Ions and molecules are then evenly distributed. All right. Nonpolar molecules, again, they do not dissolve well in water because you got to think your water is a polar molecule, so your nonpolar molecules aren't going to dissolve very well within. So for example, oils. So I always think of a lava lamp. That's how I best remember nonpolar molecules and how they do not dissolve well within water. Or if you guys look at this picture, oil within water just kind of sits on top. Eventually it breaks down. If you guys ever add oil to a pot of boiling water, eventually it's going to evenly distribute, and then you might add spaghetti or some type of pasta, but not initially. Okay, and that's because that oil is a nonpolar molecule, and that's within our bodies as well. Okay, so if placed in water or other polar substances, so keep in mind water isn't our only polar substance, the molecules are more attracted to one another versus the attraction to nonpolar substances. So your water is going to be more attracted to the nonpolar versus the nonpolar being attracted to one another. Again, that just revisits and re-highlights the terms of positive and negative charges. Okay, sorry about that. Your nonpolar substances are then shoved together. This is why you guys see drops of oil. And then this is extremely important in cell membrane structure. We have a polar side to our cells, and then we also have a nonpolar side within our cell membrane structure. So if you guys think about the cell membrane, it's not just like you're passing through one thin little layer. Rather, you're passing through a double membrane layer. And those outside portions love water. The inside portion of our cell membranes hate water. Okay, and this is how we're able to move our polar and nonpolar substances in and out of the cells. Alright, so now it's time for acids and bases. In terms of acids and bases, it all depends on what type of ions are being produced by the substance. So, for example, formation of hydrogen and hydroxide ions are being produced by one or the other. So our acids produce the hydrogen ions. When you guys do work for me, if you guys want to put H plus ions, that's fine. Okay, if it's going to be easier for you, write out hydrogen every time. I do not just want to see an H. Okay, that's not going to be acceptable. I need to see an H plus if you guys are going to use that on your work. Whereas bases, on the other hand, are compounds that form hydroxide ions, which are OH negative ions. Again, either way you guys want to write it is fine with me, but I need to see the plus and minus signs. Make sure they're written in capital letters. Okay, so capital O, capital H, and a negative sign in order to receive full credit. Okay, so one of the important things to note about our hydrogen and hydroxide ions, together, if they're being produced at a similar rate, they're going to form water. So if you guys look at H plus and OH negative, we see we have two H's and one O, H2O. Okay, and again, that's the water molecule. So as long as they're being produced at a similar rate, then we will see water being produced. Okay. So our pH scale. pH scale stands for potential hydrogen. So how many potential hydrogen ions are being produced? That's what we're looking at when we talk about the pH scale. Note we're not talking about hydroxide ions being produced. So a lot of times what's going to happen is when we talk about hydroxide ions, rather what we're saying is just a lesser amount of hydrogen ions are being produced. Okay, so I know that can be a little confusing, but like I said, in terms of bases, just less hydrogen ions are being produced. In acids, then, more hydrogen ions are being produced. Okay, so you guys might see that on one of the review worksheets, and it's just important to note, and that might help some of you guys understand the information a little better. So your acids, think about in terms of the alphabet maybe. So A being first, they're going to have more ions. Okay, bases, less ions, less hydrogen ions. Okay. So as I said, your pH scale is going to measure the concentration of H plus ions within a solution. Our range of the pH scale, as some of you guys might already know, is 0 to 14, below a 7. Okay, so anything below a 7 is going to be considered an acid. Okay, so that goes all the way up to 6.9. Neutral, all right, pure water holds a pH of 7. A lot of times, and it just kind of depends on what text you're reading, sometimes people will say 7 through 7.9 is neutral. Okay, others will say once you reach 7.1 it's basic. Okay, I'm not going to be too much of a stickler on whether you guys consider it neutral or basic, just as long as you guys are able to explain to me why you think it's either neutral or basic. Bases are above a 7. Okay, so again, acids come first. Think of, again, the alphabet. So A, left-hand side, anything below 7. Neutrals right there in the middle, and then bases are above a 7. One of the things I want you guys to add in here before we move on are the numbers regarding the strong acids and strong bases. So somewhere on your paper, make sure you guys get this down for me. Your strong acids are 0 to 3. Okay, so again, make sure you guys mark this down somewhere. Strong acids are 0 to 3. Then your weak acids are 4 to 6. Whereas your weak bases are 8 to 10. And your strong bases are 11 to 14. So I'm not sure if I even said that right there. But your weak bases are 8 to 10. Your strong bases are 11 to 14. That's what you want to make sure you guys have down within your notes. Another thing about the pH scale is each whole number is a factor of 10. So if we're moving, all right, from 5 to 7, okay, if we're moving from 5 to 7, we have to take 10 times 10, and we're actually moving up 100. Okay, so each factor is a factor of 10, or each number rather on the pH scale is a factor of 10. So 5 to 6, it's 10 times as many hydrogen ions are present. So when we're moving from 5 to 7, now we have 100 times as many hydrogen ions are present within the substance. Okay, so this is just another picture of the pH scale. I know you guys are your project regards acids and bases, and here are just some examples of different substances. If you need to, make sure you guys refer to this for your project. But these are just a few things that we picked out. Your stomach acid, as you guys can see, has a pH of about 2, so that's an extremely strong acid. That's why if you guys are ill and you guys are getting sick a lot, that's why it hurts so bad, because it's such a strong acid. Again, one of the textbooks refers to blood as being neutral, and it holds a pH of 7.5. As I mentioned, sometimes people are going to say, no, this is more basic. But one important thing to note is that our body is continuously monitoring the pH of substances that come within our body. And we have items within the body that are going to help buffer, and they're known as buffers. Either if it's too acidic, we're going to add bases to it in order to bring it down, and vice versa. Too basic, we're going to add acids in order to bring the pH back to where it needs to be. Okay, so this is the end of notes. Again, like I said, make sure you guys get that additional information I talked about on the last slide. If you guys have any questions, don't hesitate to email me. I'll be back next week and we will move forward. As I said, we're going to have a review, a project, and then you guys have a Quizlet, and then we'll be ready for a test. So I will see you guys next week. I hope you all are doing well, and be good. See you guys next week.